let's say, can you tell me what are the Fourier series coefficients? Fourier series coefficients means we express this in this form. What are AK? What are the Fourier series coefficients? Can we write this as e to the power j 2 pi t plus e to the power minus j 2 pi t by 2? That is cos 2 pi t. What is the fundamental period of that signal? What is the fundamental period? What is t naught?
1.
T naught is 1. And omega naught is? If T naught is 1, what is omega naught?
2 pi.
Omega naught is 2 pi. So what is the Fourier series representation of this? Is it xt e to the power? Fundamental period is 2 pi j k into 2 pi t. Is it the Fourier series representation? I am substituting this here. Omega naught is 2 pi. Is it this?
Yes, sir.
Now tell me what are the Fourier series coefficients? If you look at these two equations, left hand side is the same. Now you have to equate these complex exponentials on both sides. Is it? Tell me what are the how many non-zero Fourier series coefficients are there?
2.
If these two are equal, so can we say that a1, what is the value of a1?
Half.
a1 is 1 by 2 and a minus 1 is
Half.
half. Okay. Is there any other non-zero Fourier series coefficient for non-zero value for AK in this particular case?
No, sir.
No, because these two are equal. So here in this case of cosine signal, we can directly find out the Fourier series coefficients without using this analysis equation. Now tell me what about sine 2 pi t? So we can write this Fourier series coefficients are as AK is 1 for k plus or minus 1, 0 otherwise, isn't it? These are the Fourier series coefficients of sine 2 cos 2 pi t. Now what about sine 2 pi t? What are the Fourier series coefficients?
A1 equals to half and A minus 1 equals to minus half.
Is it this? And 1 upon 2j for k is 1 and 0 otherwise? Is it this? What is
Yes.
sine 2 pi t? Sine 2 pi t is e to the power j 2 pi t plus e to the power minus j 2 pi t by 2j, isn't it? Sorry, minus by 2j. Now, how to find the Fourier series representation? This is a periodic signal with fundamental period 1 and fundamental frequency 2 pi radians. So the Fourier series representation is summation over k, ak, e to the power j, k into fundamental frequency, that is 2 pi t. Now equate these two. This is also xt, isn't it, in terms of its Fourier series coefficients. Now when you equate these two, what will you get? What is a1?
1 by 2.
It is 1 by 2j and a minus 1 is minus 1 by 2j. Is it?
Yes, sir.
Okay. Now tell me, what about this? Cos pi t. What are the Fourier series? This is the notation. Fourier series. What? What are the Fourier series coefficients?
Same as above.
Above which one?
Cos 2 pi 1.
That means, is it 1 for k plus or minus 1? Sorry, when k is plus or minus 1 and 0 otherwise? Is it that?
Yes, sir.
Yes. And cos 2 pi t also, Fourier series is the same. Ak is equal to 1 for k plus or 0 for 0 otherwise, isn't it? So can we say that they are not unique representation, right? Fourier series representation. Unique in the sense, if you are given the Fourier series coefficients, can we uniquely find out the original signal? Is it possible?
No, sir.
No. It is possible when the fundamental period is known, isn't it? Is it?
Yes, sir.
If you know the fundamental period, you can find out the signal, because if you are given this information, let's say AK is equal to 1 for k plus or minus 1 and 0 otherwise, and if you are given that it is having a fundamental, it is the Fourier series, they are the Fourier series coefficients of a signal having fundamental period, let's say t naught is 1. That means omega naught is 2 pi. How to find the Fourier, how to find the original signal? It is this equation, this summation, isn't it? Ak e to the power j, sorry, this is 1 by 2, isn't it? 2 pi kt, is it that? If we know the Fourier series, the fundamental period, then we can find, and if we know the Fourier series coefficients, can we get back the that signal from this Fourier series coefficients? Can you compute that signal from the Fourier series coefficients? Is it possible?
Yes, sir.
Is it unique?
If the frequency is given.
It is unique representation. Fourier series representation is unique. That is why we always mention when you write, okay, so let me write it here. This is the standard notation I will be using. Cos 2 pi t, it's Fourier series, and I write it as t naught is with respect to this period, sorry, it is 1, it is ak. Okay, so in general, if you take any signal xt, this is the notation I will be using. Fourier series with respect to a period t naught, you have to specify this period. Without this period, the Fourier series representation is not a unique representation. Many signals can have same Fourier series coefficients. Okay, that's why we have to specify this. We have to know the fundamental period to get back the original signal, to get the original, compute the original signal. That's why we always specify the fundamental period. What is the exact value? In this case, we can write cos 2 pi t Fourier series with respect to 1. This is AK. Okay, so this is important, specifying the period. Okay. Okay, let us consider another example. Mark this t1, and this is minus t1, and this is one period. This is t naught. Okay, this is a periodic signal. So this point is minus t naught. This is xt, and this is t. Can we find the Fourier series coefficients using this? In this case, it is not straightforward. You cannot directly use the this synthesis equation to find the Fourier series coefficients. Here you have to use this analysis equation. Can you tell me what are the Fourier series coefficients in this case? What is the expression? AK is 1 upon T naught. T naught is the fundamental frequency. And this integration, in this case, we have to integrate it over one period. Suppose I am taking the integration from minus T naught by 2 to T naught by 2. This is one period of that periodic signal. You can take any interval. I am taking this. Tell me what will be the limits here? Is it minus t1 to t1 e to the power minus j k omega naught t? In this case, it is actually integration from minus t naught by 2 to t naught by 2, but this function is 0 in this interval. So it is integration from minus t1 to t1. Its value is 1 e to the power minus j k omega naught t dt. Is it this?
Yes, sir.
So what are these? So it is 1 upon t naught e to the power minus j k omega naught t by minus j k omega naught minus t1. Will you get? I'm writing the expression 2 sine k omega naught t1 by what? K omega naught t naught.